today's class we'll go for the 10th session, that is functions. Introduction of function. A function is self-contained block of statements that perform a coherent task of some kind. In a function we usually place some code which is done when we call the function. Every C program is a collection of one or more functions. A function gets called when the function name is followed by a semicolon. For example, as you can see, in main function I am calling the factorial function. So this is how it's possible. Usually in main, when we call something like CLR, SCR, we are calling some function. Similarly, call fact. Now this is how we call our functions. Even printf and scanf are also functions which take them as their arguments. So likewise, we are using functions right from the beginning. A function is defined when function name is followed by a pair of braces in which one or more statements may be present. Like you can see in Factorial, if I am going to define it, this may hold one or more statements in it. For example, you can see in factorial function there are 3 statements based on the number of requirements we'll be placing our code. Any function can be called from any other function. Even main can be called from other functions. I'm calling fact from main, and in fact I call main again. So here in main function I'm calling the fact function. When I come to fact, here I'll see call to main and again go to main. A function can be called any number of times. It's not necessary, it's not a limitation for me to say fact for one time. I can call it for number of times. I can even place them in a loop as well, an indefinite loop. Function can be called from other function, but a function cannot be defined in another function. What exactly this mean is, as you can see, I'm calling fact in main, and this is okay, but I cannot define function in main. This is highly impossible in any programming language, not only in C, whatever programming language you take, this is not at all possible. Defining a function inside another function is not possible in C language. The order in which the functions are defined in a program and the order in which they get called need not be the necessarily same. We'll take up a small example to understand the 7th point. In main, I'll print in main. Now this says that I'm in main. Now I'm calling the function. So it's clear that I'll go to function, printf in function. After function, I'll go back to main and I'll say printf in main again. Now if you see, we'll define the function at the beginning. If you see, there should be no semicolon after the function definition, as there is no semicolon after main. So this is illegal. So now you can see, first I started with main, printing in main. After that I'm calling the function, so I'll go to function, there I'll say in function. I'll come back to the main function again, printing back in main again. So the 7th point, the order in which the functions are defined in a program and the order in which they get called need not be the same. Like consider I have function 1. Now I'll go for function 2's definition. Void function 2. printf in function 2, and this is in function 1, and first I call function 1 and then function 2. Here what it says is even the function 2 is defined 1, then with function 1 later on, and calling function 1 first, calling function 2 second, doesn't matter. First I'll start with main, then I'll go to function in main, I'll come back to main, then I'll go to function 2, I'll come back to main, finally I say in main again. Function 1 and function 2. So start up with main, you'll go to function 1, there you have in function 1, you'll come back to main, again call to function 2, there you'll go to function 2, printing in function 2, again back to main, printing in main again. Uses of functions. Functions avoid rewriting the same code over and over. Using functions, it becomes easier to write programs and keep track of what they are doing. Defining functions. Any user defined C function by default returns an integer value. Syntax. The return type, function name, list of arguments. Here the return type is void, the function name is function 1, and list of argument we will see in the second example. We'll go for a small program now. I say printf enter numbers, new line character, and I call the add function, and I'll define the add function as void return type and function name which receives nothing, and say scanf %d comma ampersand a comma ampersand b if a and b are defined of type integer. Now that scanf takes some values, so print %d is the sum which is for a plus b. So your execution begins from main, you'll say print enter numbers, and call happens to add function. You'll go to add function, there you'll scan for variables. Enter numbers has been done and I'm in add function now. There it is asking me to enter values 2 and 3. So the sum is 5. Now similar thing can be modified here. In this, when it comes to passing arguments, this is what happens. I'll define the values a comma b. I'll say enter the numbers and I'll scan them. And I call the function add. But now I need to pass the values a and b which are called as arguments. So simply pass them in this way. Now a and b needs to be received in this function. For that again say int a comma int b. Need not necessarily the same variables all the time. They can be any other variables like x and y. Now say printf in function sum is %d comma x plus y. So what happens over here is in main you will scan for values, and the values scanned are I'm passing to function the variables x and y, receive them, printing the addition of received values. So let the values be 2 and 3. In function sum is 5. So this is how you can pass certain values to the function. Instead of printing the values in a function, this function add supposed to add the variables x and y. After adding the variables x and y, I use the integer sum which takes up the addition of x and y. Now I am returning sum. So here it's only adding the variables, not at all printing. I'm returning the sum. Because I'm returning an integer, mention it integer. If you return nothing, mention void. As we are returning integer, I need to say integer type. So your function returns some value, so store it another variable. S at the beginning takes 0 only for our representation sake. Now when I say printf in main, sum is %d, that is for S. So what happens over here is, you will scan the values, let it be 2 and 3, you are passing 2 and 3, you will go to that function, x and y receives 2 and 3, you are adding 2 plus 3, 5, placing it into the sum variable, you are returning 5. 5 will be taken by the variable s, which I am printing over here. So if my inputs are 2 and 3, this time I'll return the sum, that is 5, to main function, printing in main sum is 5. So this is how we can use the return statement. You can make a function to return something, you can make a function to do the manipulation or the code there itself by simply mentioning the type, what is that you are returning. If you are returning nothing, then say void. If you are returning something, then say the type of what you are returning. We'll go for some normal programming again. Integer a, let the n be the number, and I need to repeat it, the variable I. I'll scan the variable %d, ampersand n. The value given by user is in the variable n. Now call the function, placing in the loop I equal to 1, I less than or equal to n, I plus plus. And I'll call the function now, passing the value of I. Then comes, we pass I, and then we'll return it in the variable f. After that, we'll print the variable what f holds ultimately. Now in function, because here it clearly says this is a function which gives some value into f. So is it not of type certain, integer return? So that is the reason int, a function. So I need to receive it I in the same variable. I can even go for other variable, and here I say another variable f, which takes at the beginning it takes 1, and f takes f into I, and I return f. So first of all, when I is 1, I am passing 1, so it is 1 into 1, 1 into f variable, giving into f. Okay, fine. Now I pass 2, 2 into 1 is 2, return 2. I pass 3, 3 into 1, return 3, 3 into 2, and so on. This is how it happens. So finally printing the factorial of the given number. The factorial, let my input be 5 and it gives 120 as its factorial. Let my input be 4, 4 factorial 24. Similarly, the program can be modified by making the function to print there itself. Void main returns nothing. It returns integer by default. I can use a void as well by skipping the return keyword. Integer number and scanf %d comma ampersand n, simply call the function n, and here receive, because I'm making the function to print there itself, void function returns n, and here integer I comma f which takes 1. For I equal to 1, I less than or equal to n, I plus plus, and say f equal to f into I, and then finally printf %d comma f. So here again, if your input is 5, it gives 120, and if your input is 4, it gives 24. So the difference between these two programs is I'm making the function in the previous method I've made the same function to return something by using the type integer, and I made the main to print the returned value, that is 120, which is a factorial of 5. And here in this function I'm making the function to return nothing by saying the void keyword, and I'm printing there itself. This is how you can do the slight differences between the functions by using the return type, which can be void or integer, float or character based on what you are returning. Now we'll go for another similar program by using functions which prints the table for the given value. Void main, in which I'll receive the number scanf %d comma ampersand n. So simply call the function and pass n. In that particular function, because it returns nothing, receive the variable n and say use another variable I equal to 1, and the for loop I equal to 1, initialize once it's enough, I less than or equal to n, I plus plus, and say printf %d into %d equal to %d comma, the first % is for the value what I have given, and the second is for the I, and third one is n into I. So now the value what you give up to 5 into 5. If you make it up to the range of given limit 9, let it be 15. The value what I say, if it is 9, it comes up to 9 ones are 9 to 9 15s are 135 times. So this way you can use the functions concept by simply placing the required code inside a function and simply name it with some related terminology. Now, not only this style, we can go for another programming style of functions, which happens to be this. Hash include stdio.h and say void function, just define it. Void function, let the function name be function1, and void function2, which receives one integer. So simply type, these are called as prototypes. Void main, and here integer I, call the function 1, call the function 2, and pass the variable I. If I holds 3, pass it to I. Now say in void function 1, you can simply say printf in function 1, that's it, and in void function 2 say printf in function 2, sqr is %d, that is for the value what you are passing I, it is an integer, receive it in j, whatever the variable may be, use some integer variable j into j along with a comma over here. So in function 1 in main I am calling the first function, and so I say in function 1, later on in function 2 I am passing the variable I which holds 3. There in function 2 the square happens j into j, that is 3 into 3, 9 is printed on the screen. So these, either you can define the functions before the hash include the header file and the main function, or you can place the prototypes of the functions. Now what is the difference between defining a prototype and directly defining the function there itself? We'll go for a slight example which shows the difference between using a prototype and directly defining the function there itself. But the good programming practice happens to be defining the prototypes, that we'll see. Why to define, why to go for prototypes, why not to define the functions straight away? We'll start up with defining the function straight away. See in main, if I call printf say in main and call the function 1 and printf in main again, just define the function without the prototype, void function 1 and say printf in function 1. This works fine. No semicolon at the time of defining a function. So in main function 1 and in main again. Now I'll go for function 2. I'll define function 2, it can be anywhere, void function 2 printf in function 2. Now even no problem, in main calling function 1 you will be in function 1, in function 2 in main again. But if I call the function 2 from function 1, okay, so what happens? First in main, next go function 1, you'll say in function 1, next you'll go to in function 2, you'll say in function 2, finally you say you'll come back to main, printing in main again, in main again. But doing the same thing from main, I'll call function 2 and in function 1 and in function 2 I'll call function 1. Observe here what I'm doing. In function 2, in main I'm calling function 2. So I'll go to function 2. From here I'm calling the function 1. So I'll come over here. Actually, before showing your call to the compiler, before calling a function, at least two things are required. When you call a function, two things are compulsory, mandatory, that is, give the function definition before the call, give the function definition before the call which is not available, or at least provide the prototype before calling a function which is not available. So both the important conditions are not available, it gives an error. So either define the entire function over here, now it works, or say void function 1 and the prototype, even this works. So it is, we cannot mention when our requirement comes to call which function. It can be function 1, function 2, whatever it may be. So you better define its prototypes and then go for the programming concept. defining the function. So this is why we call the prototypes, mentioning the prototypes is a good programming practice.